Thank you. I'm part of the geriatric contingent of speakers, I think, too. So, and actually what the organizers didn't know is actually this is my 20-year anniversary of working on digestive health and prebiotics. So I just figured that out. So when we're talking about microbiome, there's a lot of questions about the chicken and the egg. What comes first? Is microbiome changing because something else changes? Or are changes in microbiome causing changes in metabolism and in body condition of animals? So one of the questions we've had is, do gut bacteria change with aging in pets, and why do we care about this? Do they change because the pet's aging, or are they having an effect on whether or not, or how quickly the pet is aging? So when we think about why do we care, I mean, if anyone who talks to me very long realizes that any conversation with me always goes back to digestive health at some point or another, and usually a discussion of poop and microbiome. But really, your digestive system affects whole body health. And there are a lot of new studies that are coming out looking at just what the bacteria in the gut are associated with. And I say associated with because a lot of the cause and effect relationships haven't really been demonstrated yet. But you do have effects of when you have, it might help if I wasn't, see, this is where the geriatric part comes in because I'm pointing to the screen down there, which doesn't really help you guys. But when you have inflammation within the intestinal tract, you do get some leakiness, and you can get a lot of changes in the gut barrier function, which will affect nutrient digestibility. It will also affect skin and coat condition of the animals. Dr. Williams showed some of the data yesterday related to vitamin status, particularly cobalamin, but a lot of the B vitamins are synthesized by our bacteria in the gut. And when you change the ratios of the bacteria, it can really have an effect on your vitamin status as well. It can also have an effect on body condition and coat quality. And there's a lot of research going on right now looking at the whole gut-brain axis and how your gut bacteria interact with signaling to the brain and vice versa. So some of the outward signs of aging in the digestive tract can be poor coat quality, and this could be because of poor digestibility of nutrients such as protein and fat that we see in elderly pets, particularly in cats. The data is a little less consistent in dogs than in cats. But it can be also a sign of long-term poor digestive health in general or nutritional status in these elderly animals. They tend to be less tolerant to dietary changes. So you'll have an animal, a pet dog or a cat, who used to be able to eat just about anything, but then they tend to have more digestive upsets than they would have when they were younger eating the same things. Many dogs will have an increase in flatulence. We did do a flatulence study once looking at elderly dogs versus young adults. We didn't see a significant difference in this, but it is something that pet owners will report with their own specific dogs. And you also have less day-to-day consistency in fecal quality. So you may go from, these are all number 2s on our fecal scoring system, which would be ideal. So you may have an animal who's got consistently good fecal quality every day to one that just has every once in a while a bad one thrown in there. They're not really sick per se, but they're just not as regular as they used to be, and they have increased variability in their fecal quality. Excuse me. So a lot of the early studies looked at just differences between older people or older animals and younger. And I just wanted to go through a little bit of background so that when you're looking at the literature in this area, there's a couple of kind of buyer beware lookouts to keep in mind as you're looking at the studies. First is that the methodology has really changed over time. And what we even considered 5 or 10 years ago to be state-of-the-art is actually really obsolete methodology now. And when you look at the older papers, it's good to look at how they did the studies and what type of methodology they used. Culturing was obviously it's still common, but when you do cultures to measure microbiota, you're looking for the bacteria that you think are going to change. So if you don't think they're going to change and you don't culture for them, you're not going to pick up differences. You only see who you're specifically looking for. they have to be culturable. And so a lot of the bacteria that are important are highly anaerobic. And you can culture anaerobic bacteria, but you have to use special collection methods so they don't die, and special culture methods as well. So it largely leaves out a lot of those really strict anaerobes. Quantitative PCR is a really good method as well. Again, you need to know you have specific primers for specific bacteria. These can be very specific, even to the species level, or they might be more general at the genus level. But again, you're only looking for specific bacteria that you have specific primer sets for. So you're not going to pick up, when you're trying to get an idea of overall what changes you're seeing with aging, you're not going to pick up unknown things. You're just going to find what you're looking for. I don't know if any of you have ever seen there's a video out there on YouTube where there's some people standing there and they have a ball, and you're told to count how many times the ball is passed from person to person. And so people, when they watch the video, are very focused on that. And actually, there's a man in a gorilla suit who walks right through the middle of the crowd. If you watch that video and you don't know about the gorilla, I'd almost guarantee you will not even see that gorilla. If you go back later and watch the video again, you see the gorilla because you know it's there. So my point is that if you're not looking for something, if you're really focused in on one thing, you may miss something else that's going on that's really important. The gel electrophoresis techniques were very popular probably about 10 years ago, 15 years ago. And basically, these are just techniques where you have your bacteria show up as bands. And you can see banding pattern differences, but unless you go to a lot of extra effort, which isn't very easy, you have no clue who's in those bands. So you can get a general idea of diversity and whether or not you're seeing a change in diversity, but you don't have a clue who's contributing to that. They also tend to only pick up the very top most prevalent bacteria as well, so you miss some of the minute changes that are happening. And then next generation sequencing and the more molecular methods are more state-of-the-art right now. You can find bacteria that you never even heard of, and they turn out to be highly significant, and you're trying to figure out what the heck they are and what they do. They can be very sensitive, they can be very specific depending on how you do it, and they can give you very specific changes in bacterial richness and diversity. So when we look at the literature, it's really important to compare apples to apples instead of apples to oranges. And a lot of the studies that are more population-based studies, there's a lot of confounding factors in them. So we want to look at effect of aging on microflora, changes with aging. But often the elderly have some sort of disease condition, and they're on medications for these diseases. So medications can affect your microbiome. Your microbiome can also affect your ability to use medications, too. There's actually a lot of really interesting research going on in this area right now. Then exercise level and intensity can affect microbiome by itself. So you could have two equal age-matched animals. One is exercising a lot, one isn't. That can affect their microbiome. And typically, elderly animals don't exercise as much as when they were younger because there's some arthritis going on. And maybe they don't see very well, and the pet owners oftentimes won't take them out as often. You see this very commonly in elderly people as well. Diet can obviously have a big effect on microbiome. And again, if you're doing a population study, you need to make sure that they're eating the same foods or relatively the same foods as the two cohorts of people or of animals. It's very common to see dietary changes as people get older, but also if you're looking at a population of pets, are the older animals on a senior product or are they on a maintenance adult product? Because there's differences in protein and carbohydrate ratios between the senior products. There's differences in antioxidant levels. And again, all of these can affect microbiome. And body condition is also very important. As animals get older, they do tend to put on weight. And this is some data that we showed at a nutrition forum a couple of years ago. But there are very big differences in microbiome between thin and overweight pets. So again, if your older guys tend to be more overweight, or if they tend to be thinner than the younger animals, you may be seeing differences that you're attributing to aging that are actually just differences attributed that are really due to changes in body condition. So there's a lot of things to keep controlled when you're doing these types of studies. Another question is, what's old? When you look back through the literature, and I know we ran into this in some of the studies we did, we tend to look at young adult animals versus probably the oldest guys we can find in the colony or in the sets of animals we're looking at. And so the question is, are you really looking at a regular old animal, or are you looking at a canine or feline equivalent to a centenarian? And as you can see from this research with humans, and there's quite a few studies published on this in humans, that there is difference as you get older. And there are bacteria that are correlated with people living to be over 100 years old. Just in general, if you look at older people, you get a change in the core microbiome, and you get these species who weren't very important early on becoming more important and more prevalent as the people are aging. So this is just another example. So you can see in elderly people versus centenarians, you can see pretty drastic differences in their microbiome. And there's changes in some of the beneficial bacteria, but also some of the bacteria that we consider not as good as well. Within dogs and cats, there's a lot of, and people as well, there's a lot of individual variation. These are two dogs that are about the same age, and you can see just the ratio of bifidobacteria to lactobacilli to Clostridia is very different between these two dogs naturally. In the same study, they looked at animals over time. It was a one-year study, and everybody was on the same diet, and you can just see seasonal changes. And I know we've seen that in some of our studies as well when we're looking at microbiome, which is why we always run a concurrent control group, because sometimes we'll have shifts just due to season of the year, even though a lot of our animals, they're not spending all their time outside. Diet type can have a huge effect. These are bifidobacteria levels in two different diets in dogs, and then I just threw a cat bar in there just for comparison as well. But you can see with this diet, diet A, the bifidobacteria levels were quite a bit higher than in the second diet. And in the second diet, the bifidobacteria levels are really low and the Clostridia levels are really high. So again, these are all things that you want to keep under control. There's also a lot of individual variability in Clostridia, and this can be dependent on diet and also response to the diet between different animals. So again, diet B caused really high levels of Clostridia. A caused lower, but you can see these are individual different dogs. So this is the same dog on each of the diets if you look vertically. And what you can see is that there's a difference in response of the dogs and the difference between the response to the diet in the different dogs. And this is probably due to different bacteria that are in those dogs, but it also could be due to their previous dietary history as well. So this is kind of what happens. There's a lot, as I said, there are a lot of studies looking at bacterial changes in humans as they age. One of the biggest changes you'll see in humans is a decrease in bifidobacteria. Humans are a little bit different than pets in that when we're young, not they, because I'm a human too, but you do have a lot of bifidobacteria in the very, very early stages. These tend to go down and stabilize, and then as you get older, you tend to start losing your bifidobacteria. You can also see changes in diversity as we age. And again, when you're comparing across groups, this is very important to keep in mind, because what you'll see is that early in life, we don't have as diverse of a bacterial population. And then as you get older, it's also not as diverse. So if you're comparing a young adult who's maybe almost still in that puppy stage to an elderly animal, you may miss some of the differences because their microbiota might not be fully developed and stabilized as it would be if they were 2 or 3 years old. But typically what you'll see is lower diversity as you get older, and this can have a lot of implications. And these are just some of the things that have been published in the human literature as far as what they think this is correlated with. And some of these actually are fairly active areas of research right now. If you're interested in the blood-brain axis. This is a huge area of research at the current time, and it's really thought that the bacteria in the gut are having a pretty profound effect on the blood-brain axis in aging. So when we look at dogs, this is a study that was published a number of years ago, and they looked at different areas of the intestinal tract, and they saw changes in microbiota in the large intestine, but not further up in the intestinal tract. And these changes are fairly consistent with what you see with aging people. The decrease in lactobacilli, a decrease in bifidobacteria. This is another study looking at changes with aging. This is some of our internal data. We didn't see in this study any difference overall in levels when you average them of bifidobacteria, lactobacilli, or Clostridia. I do want to point out that these are beagles, and they were 13.8 years of age at the time we did the study. This was almost 20 years ago we did this. That was about 2 years longer than the average lifespan of a beagle in our colony at that point. So I'm not really sure we were really comparing dogs who were typical aging. I think we were really looking at more centenarian type beagles at that point. But even though the bifidobacteria levels overall were the same, there were a few dogs who had really super high levels that were pulling the average up. So if you look at the dogs who were testing positive for bifidobacteria, actually about 80% of the young dogs had bifidobacteria, and only 60% of the older dogs actually had bifidobacteria. So these guys who had them had really high levels, but there were fewer dogs who had bifido. Looking at cats, this is some work that Abhi Patil and I had done, again, a number of years ago, and we did see some pretty dramatic changes with age. So you'll see an increase in Clostridia perfringens, which is an inflammatory bacteria. We use Clostridia perfringens as kind of a marker bacteria for negative things happening in the gut, and a decrease in bifidobacteria. And bifidobacteria are important because they have a lot of beneficial health effects. A lot of them are fairly highly anti-inflammatory. They've been linked to a lot of good beneficial effects in people and in pets. This is a research review that was written that just shows some of the potential effects on digestive function of changes in microbiome. For example, reduced biodiversity they've actually seen as an increased risk for a Clostridia difficile, diarrhea in people, as well as some of these changes, like enterobacteria, are pathogenic. I don't know if there's ever been a good enterobacteria that's been found. But if you have higher levels of enterobacteria, you are more susceptible to developing infections, and it's actually been linked also to colorectal cancer in people. There are a number of butyrate-producing bacterial groups, and butyrate is a really important fuel for the intestinal cells. And when you decrease your butyrate levels, you can affect gut barrier function. And so that can have some other long-term effects. So how do we affect levels of bifidobacteria and Clostridia in pets, and will that affect signs of aging? So we've done a number of studies with prebiotics. So a prebiotic is a fiber source that's used specifically by the bacteria for as a source of nutrition for them. We've always looked at chicory or inulin. Quite commonly, we've looked at other prebiotics as well. But most of the prebiotics that we've looked at are prebiotics that specifically feed bifidobacteria because we felt like they were a very important bacteria to target. And as we noted before, bifidobacteria do tend to go down, particularly in elderly cats, but also somewhat in elderly dogs as well. And you can see if you feed chicory to these cats, this is an average of a number of different studies that we did. You do see a significant increase in bifidobacteria and lactobacilli and a significant decrease in Clostridia. We've looked at the same thing in dogs and have seen the same effect across life stages. So we'll see a significant increase in bifidobacteria both in puppies, adult dogs, and senior dogs as well. So what does this do? Like, who cares? How do we know this really actually does anything? So one of the things that we look at commonly in prebiotic studies is digestibility of some of the macrominerals. We're not doing this because dogs or cats are susceptible to osteoporosis. We do this because changes in mineral digestibility are actually a sign of digestive health and of barrier function and colonic cell health. What happens is that when you digest calcium, some of it's absorbed, a lot of it isn't, and that will end up going to the large intestine. When you feed a really good soluble fiber source or a prebiotic, you'll get fermentation in the large intestine, you'll be feeding those cells, and if you can improve barrier function and functioning of those cells, you'll actually see an increase in calcium digestibility. So we use this actually as a marker of intestinal cell health. We won't go in and take intestinal biopsies. We don't do anything invasive. The FDA actually considers this to be a structure function claim for increased calcium digestibility to be a structure function claim for soluble fibers. So what we've seen is increases in calcium digestibility in both dogs and in cats, regardless of type of diet that they're being fed. So again, does this have an effect on actual functioning of the elderly dogs? This was a study we did looking at prebiotic supplementation and its effect on arthritis in dogs. And what we saw, these dogs were on this diet for 6 months. We had a control group, then the same group with 2% chicory added to it. And chicory is a source of inulin. These weren't super arthritic dogs. The maximum arthritis score is quite a bit higher than what we saw here. I would call these probably mild arthritis. But we did, after a month, start to see a decrease in arthritis scores in the animals that were on, on the chicory-containing diet, and this was maintained through the end of this study. So why would we expect this to happen? And why do we even look at it to start with? So when you look at inflammation that's going on in the body, you have all this systemic inflammation that's having an effect on the digestive tract as well. So it's not just when you have arthritis, it's not just arthritis in your, or inflammation in your guts. You have high levels of pro-inflammatory cytokines that are circulating throughout your body, and these can actually cause some damage to the intestinal barrier. And then you can get, if you have damage to the intestinal barrier, then you're going to get more enterotoxins that are going to be coming back into the body that are going to be causing further inflammation in the joints. This was our idea as far as what's happening. So what happens then, if you have a lot of Clostridia perfringens around, which we tend to see in the elderly, these are enterotoxin-producing organisms. These can exacerbate the intestinal barrier damage and increase this part of the whole inflammatory cascade. When you give a prebiotic, the prebiotics will provide food for the beneficial bacteria. These will produce short-chain fatty acids. A lot of the beneficial bacteria, for example, bifidobacteria, can stimulate anti-inflammatory cytokines, but the short-chain fatty acids can also be used as fuel for the colonic cells and can help to strengthen them and improve barrier function itself. We do see when we give prebiotics not only an increase in the beneficial bacteria, but also a decrease in the Clostridia perfringens. So this is our hypothesis for why you would see a decrease in systemic inflammation with a prebiotic and why we see the change in arthritis scores. And this is something that we fairly commonly hear from people who feed prebiotic-containing diets as well. It was actually one of the reasons we started doing this study, because when we first launched with prebiotics about 20 years ago, we were getting people calling into our consumer complaint line that their elderly dogs were now jumping out of their backyard or tripping up the stairs because they were so much more active than they were. I mentioned one of the things you'll see in elderly dogs is flatulence, and so we did do a study looking at flatulence in dogs on prebiotics. We also have similar data for Microflora, our probiotic that's on the market as well. And with the prebiotic, it does take a week or so for them to adjust to the diet. So initially, you might see an increase in flatulence, but once they get adjusted, you'll see a nice decrease. And excuse me, the peak amount of hydrogen sulfide produced, as well as the number of events per hour and the hydrogen sulfide per event. So wanted to touch a little bit on the longevity study as well. And I wanted to give you a little bit of background information on this study. So, oops, go back. When we first started working on aging, I wanted to tell you about this cat, China. So this cat, if you look at her, she looks like she's really pretty young. She was 17 when this picture was taken. And honestly, I have to tell you, when we first came up with this idea, I had a lot of people laugh at me because they said, what we want to do is have all 17-year-old cats look like this. And it's like, I was told, yeah, there's no way that's happening. You guys can't accomplish that, which we took as a challenge. So one of the things we did is we looked at different subsets of old animals. We looked at elderly animals that were age-matched, that were either looking like she did, versus frail animals who were the same age, and then compared those two groups to young adults. And we saw a number of changes. Some of these Dr. Williams mentioned yesterday, and we saw decreases in digestibility, and typically what you'll see is that the elderly guys who are, and again, these two groups are age-matched, the old and the frail old, but typically the frail guys are more impaired in a lot of the measurements that we saw than the age-matched, healthy-looking elderly. And this is really, when you look at skin thickness, this is really obvious. And you can see a number of different blood parameters that were different between these two groups of animals. So one of the things we looked at as well was antioxidant status, and this is actually where the antioxidant blend for this, the longevity study that was talked about yesterday came from. So you can see a change in urinary malondialdehyde excretion between the frail elderly and the healthy-looking elderly guys. And overall, the antioxidant status of the older cats was not as good. So we did do a preliminary study where we looked at just antioxidant supplementation. And you can see when we supplemented the diets with antioxidants, we saw an improvement in oxidative status, and we also saw a slight increase in survivability. This was not set up to be a longevity trial, but since these cats were really old, we did have some death loss on the study, and all of those cats who died were in the control group, and none were in the antioxidant supplemented group. So as I mentioned, we also see changes in microbiota cats. So when the diets were put together for the longevity study, we decided to combine the antioxidant supplementation with the prebiotic fiber to hit both of these aspects of aging. And as mentioned yesterday, there was a difference in survival between the cats who were on the different diets. The ones who were on the combo group did much better than the guys who were on the antioxidant alone group. This group had prebiotics. It also had some essential fatty acids too, because of the changes we were seeing in coat and some of the fatty acid changes that we saw that were associated with that. The antioxidant alone group was kind of intermediate, and these two groups are not significantly different, and there was a trend for improved survival there. When you look at correlations with longevity, the number of different blood parameters, as Dr. Williams mentioned yesterday, were significantly associated with improved longevity in the cats that were on the diet that contained the prebiotics plus the antioxidant and the fatty acid supplementation. So what's next? I think this is what's really exciting. If you go out and do a lit search on aging and microbiome in humans, there are tons of studies going on right now. There's actually thought that part of the reason people get Alzheimer's is actually due to microbial metabolites. So there's a lot of research going on in the whole neural area right now as far as Alzheimer's goes, but also other neurodegenerative diseases that are associated with aging. Musculoskeletal conditions have been associated with aging. cancer. Obviously, when you look at cancer, there can be a GI component to the cancer, but also response to the chemotherapeutic drugs can be affected by your microbiome. And you can be more responsive or less responsive depending on the microbiome that you have in your gut. So this is, again, another area of very active research as well. In this paper, this has nothing to do with aging, but I just think this is really cool. There's a lot of work going on with autism and microbiome, and this was actually a study that was done with autistic. It was a mouse model of autism. So what they did is they actually induced autism by changing the diet of the mother mice. And then when these baby mice were born, they were either on a control diet or on a probiotic-containing diet. The probiotic happened to be one that Nestle has in some of our infant products. The mice who were on the probiotic-containing diet did not show the signs of social issues that the guys who were on the control diet did. So again, some of the behavioral things that we see, and some of these things can be more common in elderly dogs. For example, anxiety and stress are more common as you get older. But this was just a really interesting study, so I just thought I'd point it out. So lots of cool things to come. We need to meet again in like 5 years. So, questions?
I do have a question about the blend that you used in that study. Does Purina incorporate that blend into all their diets now?
So she was asking about the blend. It's not in all of our diets, no, but it is in the Prime Plus cat formulas, which launched in the US last year, and it's been on the market in Europe for quite a while. So.
Okay. One question here.
First of all, thank you very much for this very nice talk. I think it's very interesting that you take calcium digestibility as a marker. Very, very nice. But then you had the real digestibility of the minerals, not the apparent.
With
as marker, the calcium digestibility as a marker for the gut health?
You'll see, so when you look at digestibility of the macronutrients, that's more variable. Typically what you see with protein, a lot of times when you add a prebiotic, apparent protein digestibility will go down, but it's not true digestibility, so you actually have to correct. What'll happen when you feed a probiotic, a lot of times you'll get an increase in the microbial numbers in the gut, and those bacteria have protein in them. So when you just look at how much protein you eat versus what's coming out in the feces, part of the protein that's coming out in the feces is actually from bacteria, and you can actually correct for bacterial nitrogen. So when you look at protein digestibility, it might go down when you add the prebiotic, but when you take out the microbial nitrogen content, a lot of times there's actually a slight increase in protein digestibility.
Yeah, but for the calcium, you take the apparent digestibility as marker. Yeah.
Yeah, and that's why we don't tend to use protein as a marker, just because there's so many bacteria that are contributing to that number, just personally.